Okay, fine. Fine, let's start. Okay, so any questions so far? Yesterday, I think we just introduced about the record. Okay, fine. And a record is a new feature from Java 16. Okay, so any earlier version, it won't work. Okay. So from Java 16 onwards, yes, we can use record. Okay, so yeah, so any questions which are there? Okay, fine, then we can proceed then. Right? Okay, so today what we'll do is, earlier I think we have defined a class called account. Okay, and I mentioned about a small exercise where we would like to go for subclasses of account, at least two subclasses. Okay, one is savings account, other is the current account. Right? And the requirement is that as far as savings account is concerned, savings account would inherit from account class. Right? Almost, so everything is the variables and the methods, of course, because the variables are now private. Okay, they will not be inherited. Right? But anytime you create a savings account object, because account is the superclass, we will have those things allocated. And anything which is part of account, when that constructor of superclass is always called. Okay, so allocation for instance variables of superclass will always happen. Okay, only thing is, yes, because we have declared the instance variables to be private, and they will not be directly available to us. Okay, we can use those variables because we have not directly though, but we have provided the getter methods. Right? We have given methods like get account number, get name, get balance. So you will be able to see those values. Okay, so fine. So savings account class will inherit from the account class, and maybe it doesn't make any changes. It doesn't want to override any method there. Fine. Whatever is in the account class, it's good for savings account. Okay, fine. Uh, but as far as but we need to provide the constructors in any case. Fine. What will be available will be the methods for the savings account. It will simply inherit methods of the in savings account simply inherits methods from current account. Okay, fine. But as far as the current account is concerned, okay. Yeah. Okay. So as far as the current account is concerned, for the current account class, yes, what are the requirements we have? It will again similar to the savings account. It will also be inheriting all the methods except for one of the methods there. Okay. As far as the withdraw method is concerned, for current account, we would like it to override. Fine. So withdraw method in current account should be overridden. Okay. Now, how do we override this method? The requirement here is every current account needs to maintain a minimum balance. Okay, fine. And if that balance, and if the account goes below, the balance goes below the, because of a withdrawal, right, the amount being withdrawn. Okay, if the balance is going below the minimum balance, then an additional penalty is also to be deducted. Okay, fine. Okay, so let's say we'll come across some difficulty in that case in current account, and maybe we might have to update the account class to some extent. Okay, fine. So, but we'll see what is the problem and how we should be correcting it. And then for today, another thing I would like to do is, we would like to look at the keyword called abstract. Okay, so we'll be looking at the keyword abstract. That's the next thing. Okay, so mainly discussing about the keyword abstract. Okay, abstract keyword, right? This is something which is available as a modifier for methods and classes. Okay, and this modifier can always be applied to interfaces and annotation also. Okay, fine. So let's proceed with this then. Okay, so first thing, yes, defining subclasses of the account class, which is savings account and current account. So for that, yes, let's first open the account class. Let's see what is there already. Fine. And of course, we'll make them also part of the package bank. Okay. Fine. So this is what is there in the account class. So account class which we had defined is something like this, and part of the package bank. It has the variables account number, name and balance, and as we understand, by default we are putting private for the instance variables, right? The access specifier as private. Then we have the two constructors, a constructor with 3 parameters, fine, and another and we wanted to have a constructor with 2 parameters, for which we also introduced a static variable to remember last account number. Okay, fine. That last account number has some initial value, okay, fine, which is being used. So from this point, fine, from this number and onwards, if anyone uses doesn't specify, the constructor doesn't specify the account number, fine, we will use the last account number, which gets incremented by 1 each time. So this is getting incremented by 1 each time someone calls a constructor. Okay, constructor with 2 parameters. Right? And then we have the getter methods, fine, as we were mentioning. Okay, a method to display and the method to deposit. Okay, I feel there are a few more things to be done in the account class as far as the methods of object class is concerned, right? You can see something is missing here, right? What is missing? From methods of the object class, whenever you define a class, you should always try to give a string representation. Okay, so we would like to have a toString method, fine, override toString method. Okay, so let's first finish with the account class, then we'll do the other 2 classes, right? So this is about overriding methods of the account of the object class in account. Okay, fine. So what's the first thing? At the rate, override, and we have the public string toString method being overridden. Okay, fine. A few things which we have used in display, maybe that might be useful here. So we'll say return. Okay, what do we want to return? Get class dot, which method we might use? Get simple name. Okay, right. So get class dot get simple name plus, and then we have yeah, we might use that colon thing. Okay, plus what's the next parameter? Fine, we'll like to have the this dot account number, okay, plus a comma, okay, plus, yeah, okay, this dot name plus comma plus this dot balance. Okay, so this is the kind of string conversion we are looking at now. Okay, So we didn't define the string conversion earlier for the account class, so that's one thing we have done. Another thing we might be overriding is the method called equals. Okay, so if you would like to define the equality for account objects, okay, maybe we might look at it like this, that if two account objects have the same account number, we may like to consider them as equal. Okay, so if that is how we would like to define the equality, okay, at the rate override, let's override the equals method. Okay, so we override the equals method. Parameter is object. Okay, how do we override this? Okay, so we understand what we should do first in equals method. If O is null, and first check is for the null, then return false. If O equals this, return true. Okay, fine. Very first two statements in any equals method can be these two. And whenever you are overriding equals method, these two could be the very first things. Okay, next, if O dot get class not equal to this dot get class, return false. Okay, fine. Next, just check the account numbers now. Now we, if get class here means, oh, we can always cast it into account. Fine. So I might say account AC equals cast into account O, right? O, the type was object, but we would like to treat it as account. And here, since a check has been done, so it is at least an account. Okay, then here we can just say return AC dot account number, okay, equals this dot account number. Okay, fine. So that could be the code for equals method. Okay, just one more thing. We talked about these two methods, toString and equals, but there is another method called hash code. Okay, the requirement here is, as far as the hash code is concerned, I think this didn't get discussed. Okay, so let me put some comments over here. Okay, fine. Okay, so equals yeah, there is some relationship between hash code and equals. Okay, what is expected about hash code is, or rather equals and hash code, the consistency between them is, okay, if two objects are equal according to the, okay, so if the equals method is written, equals method, okay, then their hash code should be the same. So they should have the same hash code. Okay, we have to see that it returns the same value for the hash code. Okay, and because of this requirement, okay, it's not the other way around. I mean, that if there are two objects, they have the same hash code, doesn't mean they will be equal. But if they are equal, then their hash code must be also equal. Okay, well, so hash code again It's not a final method, you can always override it. So normally how we take this rule as, okay, so the requirement becomes like this: whenever we override equals, we also override hash code. Okay, so in our case here, yes, if we want to override hash code, the idea would be that equals method has some criteria, right? For example, in this case, the criteria of equals method is it's based on only the account number. Okay, some attribute of the object is used for checking the equality. See, in case of rectangle, it was a length and width, two attributes. So the idea would be that yes, our hash code, when you override hash code, it should be based on the same parameters which are used for equality. Okay. So some kind of a functions which returns an integer value based on the attribute used for equality. So we will have at the rate override. Okay, we are trying to override hash code. Okay, so we have the public int hash code method to be overridden. Yeah, so now here, how do we want to override the hash code? It is to be based on account number. Okay, now just one simple thing here, what can always be done is, we have the account number, the type is long, primitive type long though, okay. It can always be converted into a reference type. Fine. There is a wrapper class corresponding to each primitive type. Okay. And from Java 5 onwards, we can use the cast operator. The operator is still the cast operator to convert from a primitive type to the corresponding wrapper, or from a wrapper back to the primitive. Fine. We call this as boxing and unboxing conversions. So boxing unboxing conversion from Java 5 can always be done with primitive types by using a cast. Okay, so in our case here, what we could do is, yes, how we are using it here is in this hash code method is we're saying, let's convert the account number. We have the account number, okay, or rather I should say this dot account number. So this can be converted into a reference type long. Okay, fine. I can convert the whole, so this whole expression is of type wrapper class. So converted the account number into the wrapper class, and what we are saying, okay, just return the hash code value of this. Okay, when hash code is available on all objects, so we are converting the primitive long into a wrapper object, okay, the corresponding long class, right? So now we get the long class corresponding the value of account number. So on that object, whatever is the hash code, we just return that. So we don't worry about, oh, we need to have, normally we use some prime number, take a modulus with some prime number and such things. We need not worry about it. The attribute account number, right? It's a primitive value. Let me convert to wrapper. And the wrapper class would always be taking care of having a proper hash code value for the fine for each object. So we just use that. Okay, fine. So this is how you might override methods in the account class. Okay, and these are the methods of object class. So normally, whenever you define a class, one thing you might always be having is having a string conversion. So override toString method. Okay, if you are defining your equality, override equals, and whenever we override equals, we also override hash code. So it's like these three methods of the object class. Fine. Most of the time you define classes, okay, which are having various kinds of instance variables, you would be overriding these three things. If not all three, at least the first one, the toString method, that's something you will be overriding. Fine. And so any questions about these three methods being overridden? And the way we have done the code? Okay, fine. So now let's proceed with what we want to do today. That is about defining the subclasses of the account class. Okay. Just one more change I might like to do here is, now when we have the string conversion being defined properly, okay, in the display method where we are saying system.out.println, and we have done this thing, when you can see this is almost like whatever we have done in the toString method, right? So what we could do here is, we could, instead of all this, okay, you could just be saying, okay, system.out.println, if I say this, okay, fine, we can just say system.out.println this. So this means, whenever we pass anything to the println method, it is going to convert it into a string. Okay, so current object converted into a string, so it will be using the toString method. Okay. Fine. Okay, so next, let's go for the subclass. So we go for our subclass called savings account. Okay, we'll make it part of the package bank only. So we start with the package bank, and okay, would like to have it as a public class. Okay, and the super class is account. Okay, when we say account here, current package being bank, account is actually bank.account. Okay, fine. So we are inheriting from, say, account class. We do not want any new instance variables. Fine, whatever is account is good enough for me. Okay, so we are saying, okay, so now next comes the constructors. Yes, to create a savings account, we can have the public constructors, which would take as parameter, and similar to what we already have in the account class. So it will take account number, a string for the name, and a long for the opening balance. Okay, fine. So what should be done? The first thing you do in any constructor is call the superclass constructor. So here we are just simply calling the superclass constructor, and okay, the next thing is, yes, the other constructor also, we provide the two constructors as available in the account class. Okay, so this part is quite simple. We would just be saying, okay, we'll be passing a name and long for the opening balance. Okay, fine. And the first thing we do is use super for the same things, right? Okay, so this is taken care by the, so this is taking care of the constructors.
So I have one question here.
Yeah.
So basically, when we have a two-parameter constructor,
Yeah.
for account number, we are using static field of account.
account class, yes.
Yeah, but in this case, in savings account,
Yeah,
will that account number static field?
which is in the account, right? Since we are saying super, see, understand, I have not put any instance variables here. So anyway, the logic of initialization of the instance variables is in the constructor of the super class.
Okay.
Okay, so we are just simply using that same thing.
Okay.
Fine. See, what we normally would do is we worry whenever we are writing a class. Fine. In the constructor, we will not worry about the instance variables of the superclass. Okay, that should be taken care because of the call to super. That should only be taken care. Fine. So we don't want to change the logic regarding the initialization in the of variables related to the superclass. Whatever new instance variables which you are introducing in a given class, fine, that you will take care here.
Okay.
Then that is the way we normally go. Yeah.
Yeah, but the savings account will have account number of its own, or
No.
will have account number of account class?
Okay. See, where are all the things? Account number, name, and balance.
It is an account class.
They are in the account class. So it is of that part only. Savings account has not got its own new variable for account number.
Okay.
Okay, fine. So even the get methods, right? They are, and the getter methods also, they are just inherited here. They are public in the account class, right? Okay. See, other thing, what we normally don't do, but can always be done. Okay. Let me do it here. Okay. Let's go over the account class again. Okay, fine. One thing, yes, we'll be coming back here again for some other reasons. Okay. Yeah. So account number, this is fine. Fine. Constructors are fine. What about this method called get account number? We can make this fine. Yeah. Fine. We don't want someone to, in a subclass, to change the meaning of get account number, get name, or get balance. So these getter methods, whenever you are writing for a class, fine, see to it that you override them. Okay, fine. String conversion for a subclass, yes. I don't want, I would like everyone to change the, give the freedom that in a subclass they can change the string representation. Fine. In that case, fine. See, though I have taken care of, so I am only taking care of my own string conversion, but subclass string conversion, no. Okay, equals is fine. And so look from the point of view of this also. Okay, display method, fine. Someone can have a different display, so this is fine. Deposit, yeah. What do we think? For deposit, can someone be overriding deposit? Maybe they want to introduce some other logic, so let it be, fine. So deposit, withdraw, we may not override, but the getter methods, they normally you should try to override, though we normally just tend to forget about it. Okay, and they are the instance variables managed here, they are private to me, so there's nothing which a subclass should be doing with them. Okay, so the methods here, fine, which are returning their values, should be made private. Okay, fine. So from that point of view, yes, every class, fine, look at it, that you are having a proper, wherever required, try to introduce the restrictions. Okay, put restrictions as far as possible. Okay, you should have a reason why that restriction needs to be removed. Okay. Okay, fine. So savings account, maybe I'm not interested in any other thing like overriding any of the methods. Other methods, anyway, those get methods are inherited. Okay, so let me just save this as so savings account.java. Yes, we have saved this. Okay. Fine. Let's look at the next one. Okay, so you're also interested in I could have just copied from the savings account. The initial part will be useful. Okay, so we now have the, this is going to be a current account. Let's change the name. Okay, fine, nothing much to change except for this. Okay, now let's talk about the new thing, the new requirement. What's the requirement? All current account will have to maintain a minimum balance. Okay, so what we could do is provide a, when this minimum balance is the same across all the current accounts. It's not that, oh, particular current account will have a different minimum balance, another account will have a different minimum balance. So it's not an instance variable, right? We want minimum balance to be there, but not as an instance variable. It will be a static variable. Okay, type is long, and variable name we'll call it as minimum balance. And we have some initial value. For example, in our case here, we might say, okay, let that minimum balance be 10,000. Okay, so we keep some minimum balance, and we would like to have a value for the penalty amount. If a withdrawal takes it below the minimum balance, okay, so we will have a penalty amount. Okay, whose value, yes, we might keep, maybe we want to keep it as penalty can be 500, or maybe it's too heavy, we can say 200. Okay, so we have a penalty amount of 200 in case the balance goes below the minimum balance, okay, because of a withdrawal. So at the time when he is withdrawing, we'll make this penalty. Okay, okay, so fine, let's see, at the rate override. Now we are overriding the withdraw method. Okay, withdraw method takes parameter as amount to be withdrawn. Okay, fine. So, sorry. Yeah, so what's the first thing we'll do here? Even before I go for the minimum balance check, okay, I would like to carry out the check whether he has sufficient balance at all or not. Okay, so if he has balance, then, so if he has got the balance, then we should allow him to withdraw. Okay, but after that withdrawal has taken place, if the balance goes below the minimum balance, additional penalty amount also to be deducted from the balance. Okay, so that is our logic. So first thing what we could do is we could use the method as available in the superclass. Okay, so that can be done by saying if not super dot withdraw amount. So when we write this, if not super dot withdraw amount, what is happening in this? It is using the withdraw method of superclass, and if it is failing, okay, that means he doesn't have a balance. So in current account also, we are not allowing him to withdraw. So we are saying return false. Okay, but in case there is balance, the withdrawal was successful, that means this method would have returned a true value. So when this has returned a true, the withdrawal has taken place. Okay, the amount has been deducted. Now we go for checking if the balance falls below the minimum balance. Now if the balance, okay, we can say get balance is less than if the get balance is less than minimum balance, right? We have to use get balance because balance is private. Now tell me, how will I detect the balance? I have to deduct the penalty amount. Okay. Sorry. So one thing what someone might like to use, right? Now we would normally be liking to use a code which looks like this dot, not this, but at least super dot balance minus equal to, okay, we are interested in deducting the penalty from the balance. Okay, so one thing now what we are seeing is that balance is to be used in the account class, in the current account class. I need the access to the balance. So here I feel, yes, it's an idea that we should be giving access to the balance. Okay. See, we restricted account class instance variables, said, okay, everything should be private. But now when we find that somewhere, it is necessary that we should be opening up the accessibility to balance. And only then we go for change in the account class, and we'll say, oh, we need it in the subclass, but this subclass, understand, is part of the same package. Fine. So we don't intend that there will be subclasses which are going outside the current package. Okay. So from that point of view, yes. So it's all a decision based on how you perceive the thing. So here we would not make it private, fine, but we can leave it as package level access. Okay. So within the package, any subclass, not only subclasses, any other class which is part of the package band is going to be able to access the balance. Okay. So giving accessibility to default accessibility to balance. Fine. We have changed it from private and made it default. And then yes, let's go back to the definition of current account. So in the current account, fine, the withdraw method which was to be overridden, yes, we are in this, we are updating the balance. Okay, so we can save this as okay, so this is saved as current account.java. Okay, and so overriding of withdraw method in the current account, that's what we have done. Okay, fine. So this is related to the exercise, I think 6.1, 6.2. I'm not sure. There's only one exercise in that chapter. 6.1 probably. Yeah. Fine. So any questions on this? Okay. Fine. Let's then proceed to the next point in our for today, and that is about the abstract keyword. Okay. Yeah. So what is abstract keyword? Okay. I think this we have done these and these things. Okay. And in fact, we also done overriding of methods of the object class in the account class. Okay. So what do we mean by abstract? Let's start with that. Okay. So what is this abstract keyword for? Abstract keyword. It's a modifier for methods, okay, methods and classes, okay. And also and it's also applied, you can it's optionally applied. So the idea here is interfaces and annotations. You may say, oh, I am writing an abstract interface, right? Or I am having a abstract annotation. The keyword abstract can be a modifier for both of them, but it would be like redundant, okay, because you are defining an interface. It is always abstract. Interfaces and annotations are always abstract. So even if you just ignore the word and don't put abstract for interface, it is always by default also abstract. Okay. So we have concept of abstract classes and abstract methods. Okay. Okay. So we will be discussing about abstract classes and abstract methods. Okay. So what is an abstract class? Yeah. So what is an abstract class? Okay. So abstract class is nothing but there won't be any object of such a class which is abstract. Okay. I should be saying for its non-abstract. Okay. For example, okay, we have a class called vehicle. So do we have object of vehicle alone? Can we say, oh, I would like to have a vehicle? what we get are, we don't have objects which are just a vehicle alone. When they would be object of the subclass of vehicle. When we find objects of the, okay, so if we have a class for which we find that, okay, the objects are always created of a subclass. Okay? In that case, that class must be abstract. Fine. So, okay. Now another thing here, as I mentioned, yes, we have abstract class and abstract interface. Okay. Same way, see, just from that point of view, look at our class account. Do we actually have just account alone? Do we create just the account only? Or we create objects of savings account, current account? Maybe someone might have some more kinds of subclasses of account, like, oh, another kind of account could be a recurring deposit account. Right? So different kinds of accounts may be there. So account as a class, yes, it is there because there is some common logic among all of them. There is a type called account, but account has subtypes whose objects are created. Okay, fine. So that means this is a class. Okay, fine. Which needs to have subclasses. Okay, this is a class where we would like to have subclasses. The objects of this class cannot be created. Only if there is a subclass, then the object can be created of the subclass, provided that again is not an abstract class. Okay, fine. See, class hierarchy could be something like, oh, I have a class called vehicle. Okay, so we are saying this is abstract. Okay, so abstract class vehicle. Okay, I'm not writing the definition here, but we have an abstract class called vehicle, and someone says, oh, let's have a subclass of vehicle, and again he says, I want to have an abstract class called car. Car is abstract, and this car is abstract because we are saying we would like to have a class called Maruti car. Okay, it's again a, I would like to look at it as an abstract class again and say, oh, we have now got a class. So a proper class which I am giving here is a class called Maruti Zen. Yeah, there is one model called Zen, right, for Maruti. So we would like to have a class. Now just see what are the objects created of. Do we have some object which is just only a Maruti car only? No. What is being created is, this is, someone has defined a model called Maruti Zen. There is a specification for Maruti Zen, and what is being manufactured, what objects are being created are the objects of Maruti Zen. Anything which is a Maruti Zen is always a Maruti car. Okay, anything which is a Maruti car is always a car, and it is always a vehicle. But those are subclasses whose objects are not directly created. The objects are only of the subclasses. Right? See the first three classes, object is not created. This is the thing for which actual physical objects are getting created. Right? So anything for which physical object is not directly created, but has subclasses, subtypes rather, whose objects are getting created, and that is what should be non-abstract. Otherwise, yes, you should have them abstract. Okay, so by mistake also, no one will be allowed to create an object, right? Because vehicle is abstract, okay, because vehicle is abstract. Okay, let me put it as a next statement here. Okay, so okay, so we cannot create object of vehicle as new, calling the constructor to create object, right? Using with the keyword new, right? Okay. Okay, someone will confuse with this. So this is what is not allowed, okay? Right? Something like this, just as an expression, this thing, saying, oh, I have a vehicle object. No, you cannot create vehicle because vehicle is abstract. Okay, because vehicle is abstract, an object of vehicle cannot just be created like this. Of course, if we have an object of a subclass of vehicle, it is a vehicle. If someone tests instance of vehicle, yes. When someone has created, if we consider this class hierarchy, right? Okay, like a vehicle, car, Maruti car, and Maruti Zen. Okay, of course, each one will have their further subclasses, right? For example, vehicle will have a one sub. I just written one subclass called car. There will be other subclasses. Okay, there can be truck, there can be bike, and other things. And then we can have again, if I look at car, just the car itself, oh, it has various subclasses. Fine. Okay, but then this particular subclass called Maruti car has a subclass called Maruti Zen, which is not abstract. And there are other subclasses of Maruti car, which will be probably most of the time they will be non-abstract. Okay, so of course now what is being allowed? So calling the constructor of Maruti Zen to create an object is valid. So what is valid here? Okay, okay. So what is valid here? New. Okay, this is valid because it is not abstract. Okay, whereas here calling constructor with some parameter, not valid. Okay, so fine, this is for all of these, fine, it would be not valid. Of course, let me put that to be more specific. Any kind of constructor someone is trying to call. Right? Okay, so fine, that is clear. The distinction between a abstract class and a non-abstract class. It is about object creation. Okay, that's the first thing. Okay, now I was also mentioning that we have a concept of a abstract method. Okay. Okay. Okay, so what is an abstract method like? So what are abstract methods? How do we normally have a method? The syntax for a method, what is the syntax for a method? Syntax is, oh, we can have some modifier. Okay, so there can be multiple modifiers maybe. Okay, I'll put it this way. It's optional to have modifiers for a method. Okay, but yes, there are multiple such modifiers. Then final is one modifier we have seen. The access specifiers which we use, public, protected, those are modifiers. And again, now we have another new modifier called abstract also, which is applicable to a method. Then we have the return type for the method. Okay, then is the method name, and then is parameter list. Okay, a list of parameters, a declaration of parameters. And of course, there are a few other things here after this, which we'll look at a later stage. Okay, so in general, it is like this. Okay, so oh yeah, one more thing. After all that, yeah, what's the next thing normally? So after all this, right? After, okay, here the dot 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 which I put was for a clause which we use. I've used it earlier, so we have a throws declaration. And once the throws declaration is done, which is again an optional part. So a method in general has this kind of a syntax. Okay. After this, yes, now what next? This is the method declaration. Okay. But then this declaration can only be a declaration. This is the method header. It can just be a declaration. For certain cases of modifiers, which includes the abstract modifier, you may just put a semicolon saying, okay, we have a method in this particular class which is abstract but has this kind of a this method would take these inputs, so there are those parameters. This method will be returning a particular type of value. You have a mention of a return type, and of course there's a throws declaration which is also valid here. Okay, so one option is this. The most common thing which we have used so far is the syntax in which we have the so there is the method body. And what is the purpose of the method body? It shows that if this method is used, this is how the things will be carried out. Okay, someone wants to have this operation to be done. Okay, this is how the operation actually works. Okay, the working of the method is specified in the body. But in case of an abstract method, so this is the general thing which we have seen so far. I'll just repeat the whole thing. Okay, here in the modifiers, okay, dot dot dot, yes, there can be other modifiers. I'm just adding a modifier called abstract. Okay, in case it is abstract, then we are not talking about the body. Okay, it would simply have a semicolon. Okay, there's yet another modifier. So among the modifiers, one is abstract, and another case is where we use the modifier as native. There are two modifiers for which method body is never mentioned. Instead of a method body, we have a semicolon. Okay. When the difference here is the modifier list. Though I have said modifier because maybe it is for something like saying public or some such other things. Okay. So you may have other kind of modifiers, but if among the modifiers you have the modifier either abstract or native, okay, in that case, okay, you will be having a semicolon at the end. There is no body. You cannot mention a method body for these two cases. So abstract method is one thing for which no method body is mentioned. Okay, it's like saying, oh, so inside a class, if I'm putting abstract methods, I'm just saying, what are methods? Methods are the list of operations which can be done on objects of this type. For this class, what are the list of operations which can be done? Oh, these are the methods I'm having. Okay, so even an abstract method is that only. Even an abstract method is nothing but it is forming the list of operations. Methods are just nothing but the list of operations. Right? For all the methods, I am mentioning how the operation will be performed. Okay, fine. So method declaration is my list of operations, and along with that list of each operation, I am mentioning for each operation. Okay. Fine. Not only in a class definition, inside a type definition is a list of okay. So if someone has defined an enum and put a method inside the enum, oh, it's about that enum. So I'm just using the general word type rather than saying class. Okay, but yes, we can consider class as an example and look at it from that perspective. So methods in a type define in a type definition. Okay, let me put the word fully. Okay, fine. This is one thing. Method body. Okay. Or rather than how, let me put it as steps. Okay, it includes how the operation is in bracket. It is nothing but the steps. Okay, steps for the operation. Okay. Fine. Okay. In case of abstract method, fine, the how part is missing, is not given. Right? So if it is abstract, we're not saying how it will be done. We're only saying this operation exists for the type. Okay, fine, but we don't specify how it will be performed. We're not giving the steps of the operation. Okay, now what about the native? I was mentioning even native we don't give a method body. So in case of a native method, the how part is not written. in Java. It is not that it doesn't have the how part. The steps are there, but they are not written in Java, and therefore, okay, the steps, okay, the how part, not therefore, okay, the how part is given in a native language. We say it is a native language like C or C++. Okay. So someone wants to write a method's steps, the code for method in C or C++. Oh, that is where he declares, yes, we have this class having a method which is so and so method, so this operation is there. But then you can't, I would like to write the code in a language like C or C++. So you declare such method as native. You are not giving the code here. You will have to separately write another file which is in the language which you intend, C or C++. Okay, and write the code for that over here. Fine. The operation, the steps are specified there, and that is how it is done. So the reason for not having a body in native is different from what is it for the, so abstract means I'm not giving the steps. No steps mentioned for this given class. Okay, fine. Let us look at a simple example like this to understand. Let's try to relate with some other type where such things will be there. Okay, okay, we can even consider the vehicle class also, right? So let's just try to write some kind of a coding which looks like this. The class vehicle, okay, of course, it we would not like to have objects, and therefore we are saying, oh, this is abstract. Okay, we are saying this is abstract because we don't want objects to be created. That's one thing. The reason for abstract is we don't want the object to be created. Okay. So this class vehicle may provide. Okay, now the other thing here, just one more point. Okay. Abstract methods are allowed, or rather I should say are not allowed. Okay, let me put it as are allowed in okay. So which are the abstract types we know? Abstract classes, interfaces, and annotations. Of course, there is a case we will find abstract method appearing in some of the enums. Okay, but the enum won't be abstract. Okay. We do have a case where okay. The enum won't be abstract. You're not allowed to declare it as abstract. Okay. So enums not allowed to be declared abstract. Anyway, we'll talk about when we look at the enum type. Okay, what exactly it is and how it is done. Okay, but just to make the correction in the statement. So in general, yes, you can take this as the statement, which is abstract methods are allowed in abstract types only. So you may have a enum which is containing an abstract method, but still it is that enum is not declared to be abstract. We can't declare say, oh, this enum is abstract. That's not allowed. Okay. We'll talk about when we look at the enum type. But as far as the classes are concerned, yes, interfaces, annotations, they are anyway always abstract. But for classes, only abstract classes may have abstract methods. Okay, so abstract methods not allowed in a non-abstract class. Non-abstract class we may also refer as, okay, and it may be referred as concrete class. Concrete class means the objects are something which can have objects, physical objects. So we are calling it as concrete class. So abstract class and concrete class. Rather than saying non-abstract, you can even say it's a concrete class. Okay. So going for the abstract class, let's see. Okay, as an example, yes, we may have a class called which is vehicle class, which is abstract. Okay, so what could be the abstract method? Vehicle would have what kind of methods? Every vehicle would have methods for start, right? Okay, so we have start. So start would be a method, and we'll say, okay, we have a method called start. We're saying it doesn't require any input. Fine, whatever is the vehicle, just call start on it. It should get started. But then I'm not going to say how it is done. Vehicle doesn't specify how it is done. Okay, we would have other abstract methods as well. Okay, start, stop, accelerate, and also things. We can also, someone says, oh, we do have a method called run. Okay, so vehicle has to run. Okay, fine. Next step, we go for the subclass of vehicle called we had an abstract subclass called car. Okay, and what does car do? Okay, maybe I'll keep another method also. All vehicles will have wheels. Okay, so we can say, okay, we have an abstract method again, returns int wheel count. Okay, but this is abstract. Oh, these are abstract. So semicolon at the end. Okay, fine. You may be having more things, right? Okay, I'm just giving part of the code, right, which is relevant to us. Now to understand this, now when someone says I'm extending from the class car, I'm extending from vehicle, and he says, okay, fine, we have one method which is abstract and I'm overriding. Okay, I'm overriding the method wheel count to return 4. Okay, fine. You have not done anything else here, which only means that you have not specified how the start or the run method or the fine, but one of the methods which is abstract has been overridden. We have just overridden one abstract method from the superclass. Okay, but what about the class car? Does this class car have abstract methods? Yes or no? This is, if this is the definition you are looking at, there's no direct declaration of an abstract method in the class car. Okay, how many methods available for class car? If there is a car, out of the list which we have mentioned here, okay, how many methods are available? There are 3 methods which can be used on an object of car. Okay, see, also understand one thing, though the method here is abstract, right, I have a v equals, let's not worry about how it will be done. Okay, fine. So if we have a reference, the type is vehicle V, okay, then V dot start is valid. Okay, V dot stop is valid. Okay, V dot run is valid. Okay, these are all valid because these are the operations available if I have any vehicle object. I won't have vehicle V. Can it have just a vehicle object? No, that can never get created. So V cannot be referring to something which is only a vehicle. Okay, find something which is only a vehicle. No, we can never be referring to such a thing. Right? Whereas if I look at the class car, okay, fine. If I look at the class car, I don't find any abstract methods being declared in the class car. But does it have abstract methods? Answer is yes or no. What is it? Does car have abstract methods? What methods available for car? I'm inheriting from the superclass. What have I inherited? I have inherited the abstract methods. This one I have overridden. This one has been overridden. That's fine. Okay. But these two methods have been inherited and they are abstract. So they are abstract even for the class car. So class car is abstract. Okay. Okay. Next one. We have the abstract class called Maruti car, which extends from car. Okay. And what it has done is it has said at the rate override, and I can tell you how. So I have this method returns void, name of the method is start. I know how Maruti car starts. I have all the steps for how to start a Maruti car. Okay. We have other method was run. Okay. So we have the run method and it says, I can tell you the steps for run. We have the method that anyway is inherited. It's not. So this class doesn't have any abstract methods. The idea which I'm mentioning here is we do have a class with no abstract methods. See, the three cases are different. The first case, vehicle, is of a class which is abstract and has explicitly abstract methods which we can see. Or these are method declarations which are abstract in this class. We have another class which is having no abstract method declaration but has abstract methods. Okay, so this can never have been a abstract, non-abstract class. This class could not have been a non-abstract class because it has abstract methods. You haven't declared it, but you haven't overridden the abstract methods which are part of the superclass. Not all abstract methods of superclass are overridden. Something you have overridden, but not all of them. Okay. Here is a class, Maruti car, which has no abstract methods. Any abstract method which was there has been overridden. Okay. All abstract methods have been overridden. Fine. Yet, I declare it abstract. This is valid. Okay. Class with no abstract methods can be declared to be abstract. It would give a restriction that no, someone will not be allowed to create the object of this. You can't say new Maruti car. Here, abstract means no, you cannot have object of this. But now if someone says, I have a class called, okay, we have a class called Maruti Zen. extends from. Okay, fine. So this class I have not declared abstract. Only thing I have to ensure is I'm not introducing new abstract methods. The superclass doesn't have abstract methods. If there were any abstract methods in the superclass, I would have to override for this to be a non-abstract. Okay, for Maruti Zen to be non-abstract, it must override any abstract methods of Marutika. Maybe Marutika doesn't have any abstract methods. This is also fine. You may have added new methods. Maruti car in general has certain things, but Maruti Zen has a few specialties. Okay, it may have some additional methods. Okay, but no abstract methods to be added. Fine, it is not allowed to have any kind of abstract methods. Okay, no abstract methods, whether declared or inherited. Fine, either being declared or being inherited. No, you can't have inherited abstract methods as well. Okay, so that is what a car is. Now you could be creating new Maruti Zen, and that's what is happening, right? Objects which are created in physical form. What is created is objects of the class Maruti Zen. Okay, fine. You are never having object of the class just Maruti car. Then you are never having object of the class car. Of course, a Maruti Zen object is a Maruti car. A Maruti Zen object is a car, and it is a vehicle. Then clear the hierarchy wise. Okay. So keyword abstract, right? And where it can be used. So when used with a class, one thing is it is for. Okay. Now my question here: what about the constructors? Can an abstract class have a constructor? We are saying, oh, we can't create an object. So can vehicle have a constructor? Let's think in this term. Can vehicle have a constructor? Yes, because you can have maybe. Why do we have constructors? So, oh, maybe I would like to have a variable called the type may be date. So every vehicle, when it is created, there is a manufacturing date which it is required to have. Okay, fine. So you have instance variables. If you have instance variables, you would like to have their initialization, and therefore you might provide a constructor for vehicle. See, you have constructor which is taking date as a parameter, manufacturing date. Okay, so manufacture date is a parameter for this, and yes, it has done the initialization here. Okay, I'm not writing the code specifically, but yes. So constructors are there even in the abstract class. How are these constructors going to be used? We say we can't have new vehicle. How are these constructors used? The constructor will be used from the subclass. Okay, the subclass will always be using constructor of the superclass. We understand that. Okay, so a public someone says, oh, this is car. Okay, maybe you are taking some inputs. I'm not writing about that, but it is using super as the first thing. Okay, so these constructors which are there in abstract class are also usable. Okay, they are used by the constructor of the subclass. So subclasses using constructor of superclass, that is always happening. So abstract class is just like any other class. Okay, fine. With a additional advantage of allowing abstract methods inside them. So abstract classes in turn have additional form of method, which is the abstract method. Non-abstract class, no, they cannot use abstract method. They cannot be having abstract methods. And clear the abstract keyword. We have abstract class, we have abstract methods. Okay, different cases of a abstract class. Okay, fine. I'll just try to show it on the board maybe. Then any questions you get from what you have seen so far? Okay. See, one thing, you understand one thing, that as a user of a type, okay, if somewhere I have a type vehicle, fine, I do not worry about abstract methods. Okay, we understand that abstract method is something for which the steps are not mentioned. Okay, the steps have never been specified how it is done, right? That how part is missing, right? These classes are all data types. Anyone who uses a data type needs to know what operations are available. Okay, fine. Only one who has to worry about what are the abstract methods in a particular class is not the one who is using the class, but is the one who is using it in a specific manner, who is creating a subclass. The one who writes a subclass worries about, oh, what are the abstract methods in my superclass? Nowhere else they will worry about the abstract methods. Oh, this method is definitely available. Any method, even if it is an abstract method, you have to think, yes, it is always definitely available. Okay, and anyway, you would never have a case where a method you will be trying to, you have written a code where the invocation of a method happens such that the steps are not available to me. No, that will never happen. Let's see how. Okay, fine. Let's try to understand here. So we're trying to understand about the abstract type. Yeah. Okay, so this is related to abstract. Okay. We have the class vehicle. Okay, having subclass called car. Okay, this has a further subclass called Maruti car. Okay, and then we said, okay, let's have a further subclass called Maruti Zen. And that's how it is. Fine. We understand that this will have an object. We can't have object of any other type. The object which will be created will be object of Maruti Zen. Okay. See, which method gets invoked is decided by the object. Now, in Maruti Zen, you have not inherited any abstract methods. Okay. So even if someone has said, see, what is happening is vehicle V, what can be assigned to it? What can be assigned to it? Anything which is a subtype of the vehicle, right? Anything which is a subtype of the vehicle. Okay, fine. So what can be assigned? Yes, it could be, if someone says C, for example, oh, there is a car C. But then car C, what can be assigned here? How that car C would have been assigned? Oh, it would have been assigned maybe a Maruti car, or someone has said, no, let me just create a new object. Now, can he create new for anything which is non-abstract? Then it can't be done. He can only use Maruti Zen or any other non-abstract class and create a constructor from here like this. Okay. So if I'm using V, right, what I will be doing with V, I don't need to worry about what are the whether a method is abstract in the vehicle or non abstract. Okay. What are the list of methods available for vehicle? That is what is invocable by. So when I write a code, yes, V dot, I will use any method name which is available for vehicle class. Don't worry about anything else. Oh, it is abstract or not. When you are writing a code where you're trying to invoke a method, okay, don't worry about abstract method. As a user, you don't worry. Only person who has to worry and look at, oh, whether it is abstract or not, is the one who is writing a subclass. Fine. Fine. Subclass of an abstract class. Writing subclass of an abstract class, just think, am I having any abstract methods in this? In the superclass? If they are, I will have to worry about how writing the steps for it. So ultimately, anyway, methods are always invoked on object, or it would be a null. If it is null, you are getting an error, null pointer exception. If it is not null, then it is a physical object. Physical object is created for something which is concrete like this, where no abstract method is available. Method bindings always happen at runtime, right? Which method? So there's no question of an abstract method being bound to some kind of an invocation. No invocation will be saying, oh, I'm doing it on a I don't have abstract methods which are getting invoked by anyone. Of course, those methods have been declared as abstract. So v dot I'm using, maybe I'm using the run method. Okay, but that is not actually a abstract method. V dot run will be according to what V is referring to. It's referring to a Maruti Zen. It cannot be referring to some other Maruti car or a car or something. Fine, we don't have objects of car or Maruti car or even vehicle. Okay, so objects are always created of a concrete type. Okay, concrete type do not have abstract methods. Okay, fine. So abstract, fine. Concept of abstract, the keyword abstract basically. Fine. When a class should be abstract. So now in whatever we have done so far, we have those three classes, right? We have account class, savings account and current account. Yeah, what do we think about the account class? Do we want to allow someone to send new account? So we would like people to have either a current account or a savings account. or if at all any new other type, it would be a kind of account, but just account, no, that's not there. Okay, so you can have, see, account class was created as a proper class with all the things, right? Variables, methods, constructors. Okay, we have instance variables, we have methods. Because we have instance variables, we are putting constructors to initialize them. Okay, and yet you can go ahead and declare the class as abstract. No abstract methods in that class. Okay? Because you declare account as abstract, anyone who sees this account, he is, in order to use this class, he has to create a subclass. You are forcing inheritance. You are designing this class as a base class. We call it, oh, it's a base class, which will have its own further subclasses. Okay, fine. So very common to find abstract classes in Java library. Right? So you'll find them in Java library very much. Okay. See, few other examples which I might like to mention here. Okay. See, just to relate this concept of abstract, let's say we have something called numeric type, right? All numeric type will have, if there is a type called numeric type, they all will have a addition, subtraction, multiplication, division. And yeah, modulus also you might have, right? So all numeric type will have these. So we have a set of operations, right? Now, how do I add two numbers? How to add two numbers? The steps for adding numbers, they are not known at the level of numeric type. You have numeric types which are whole numbers like int and long, and you have numeric type like float and double. They are following a different kind of a format, and they are following the IEEE 754 standard. If I have to add, what are the steps for adding two integers, fine, or maybe the two long, they may be same, but that's not for all kind of numeric types. When I say numeric type, a numeric type is abstract. It would either be a whole number or it would be a floating point number. Among the whole number, it may be a byte or a short or an int or a long. Fine. And among the floating point types, I will have float and double. Fine. Each one individually has its own steps. Oh, this is how addition is to be done. The steps for adding numbers is known once I know it is a whole number. Fine. The steps for int long may be the same. The steps for float and double will be the same. But if someone looks at the numeric type level, no, I don't know the steps for this. It always is going to be determined by the subtype. Okay, the how part, the steps, right? So that is what is the abstract is, okay, saying I don't worry about the steps here. I'm not giving you the steps. Fine, clear? Okay. So yeah, that's one thing. Just to introduce to the next topic here. Fine. Just think of, I'll just redraw it again because otherwise it will result in overwriting. Okay. We have the class called vehicle. Okay, but we have something called the subclass of vehicle. Car was one. Okay, what about aeroplane? We have a subclass of vehicle called aeroplane, right? And aeroplane is also, so one super type from aeroplane perspective, What is the super type? Oh, it's a vehicle, right? Another super type for aeroplane will be, okay, another one can be, it is a flying object. So I have a super type, two super types for aeroplane. It is a flying object and it is also a vehicle. Okay. So what is this thing called flying object? In Java, we can't have two superclasses which are directly inherited from. You can't be saying a class extends and you can't give two superclasses to it. A class always have only one superclass. Okay? A class will only have exactly one superclass. So here, yes, vehicle is a class. So what is flying object? This cannot be a class. Okay, so it's not a class type. What is the type? Here, see, the term used here is, oh, we can't have multiple inheritance in Java. Okay, but when I talk of multiple inheritance, we have to look in various perspective. Okay, we have got, we can say, we have multiple inheritance of types. If I look at types, yes, this has got two super types. One is a class. What is this flying object? The flying object would nothing but it would be a interface. And the reason why we would like to have it as an interface, right? It's not because I want multiple inheritance, but there is a different reason why it is an interface. Okay, why a particular type is an interface? Okay, why flying object is an interface? Because one thing, it doesn't maintain instance variables. It has no state information. There are no instance variables for a flying object. Okay, so fine. Fine. I think we'll continue later. And for today, I think this is quite good enough. Fine. So abstract, fine. I think, but I got good idea about what is abstract and what that keyword is for. Okay. And so still any questions? Yeah. When was it disconnected? Tapan, Harshit? Yeah.
Yeah, I have one question.
Yeah.
So, can we have an abstract class without any abstract methods?
Yes. And for example, we have the class account. Fine. This class is designed for having subclasses only. Fine. The idea is it is designed for subclasses. Okay. Fine. This has instance variables. I will put the constructors. I'll have instance variables. I'll have constructors. I will have proper methods. I do have an option. I do have an option of having abstract method in it if I want. Fine. But I don't feel a need to have an abstract method. It is okay. Okay.
Okay.
Fine. So, fine. Abstract class without any abstract methods is also fine. Fine. So we can actually do this change also, right? In the class account, we may go ahead and make it abstract. So no one will be allowed to create an object of just the account only. Go for subclasses, have subclass, then create objects and use only the objects of the subclass. Okay. Constructors are there for initialization purpose. So you have instance variables, you will have constructors. Any class having instance variables would normally have constructors. Okay. Okay, and then we fine. And I think I don't know whether this it got disconnected when we had, I was looking at this, trying to introduce an interface. That's the next thing we will be looking at. Fine. Someone wants to have a class aeroplane and it has two super types. One is vehicle and other is so aeroplane is a vehicle and aeroplane is also a flying object. Okay, fine. A class cannot be having two direct superclasses. Okay, here we'll find that yes, flying object should be an interface. Okay, so yes, we would like to now introduce interfaces. And also when we look at interface, we'll try to use another type of interface which is from Java 8 called the functional interface. Okay, fine.